Okay, we're back again, Autodesk Inventor Professional 2020. Now, from the last discussion, we have talked about the basic function of using the Loft. Now, let's go dig deeper on the other functions of Loft. Now, I will make taking my exit plane visible. So, I will be trying to draw my sketch here. Notice that you have here your center point. So center point, so that will be in the plane or in the paper, that will be the 0, 0 point, which is 0 mm and 0 mm. So that means that is the center of origin, or the center of origin of our. So I will try to create a circle here, so that is in the coordinate of 0, x, and y is 0 also. Okay, you notice that one as I hover my mouse on the center point, and I'm giving this dimensions, giving this as 100 mm. Then let's try to zoom out, zoom extend to see all the view of my sketch. So notice here we have fully constrained my circle. Okay, so let's try to bisect this circle. So initially I will try to bisect this one. So we are on a line that is a construction line. So our construction line is represented with a dotted line. Okay, so that represents that one. And also let's try to constrain this one. So this is now fully constrained. Again, I will be drawing a line here. So from this circumference point, then going here. So click escape. So we have this one are fully constrained. Now let's try to bisect this one also. I would like to bisect also this quarter circle. So let's make this as a 45 degrees. Okay, so time to do that one, try to escape. So we have dimensions to constraint, so 1 dimensions. So I will give this one an angle to have a call this constraint. So I'm gonna make this one so 45 degrees. Now it is fully constrained. And I would like also to bisect this one. So try to do that one, bisecting this. That is almost half of that 45 degrees. So I'm going to press escape. So we still got 1 dimensions required to constrain. So giving this one dimensions. So here I will try to employ a simple equation just to make it parametric. So we have this one. So clicking this one, we have the D94. So that represents the distance of this one. So I'm gonna give this one as a symbol of slash. So that means I'm going to divide this one by 2 to represent that the diameter of the angle of this one. So this is now dependent on this angle. So my mirror line, okay, I'm going to mirror this one. So I'm going to do is to select this line, and we have your mirror line here. So I'm going to click apply. So we have created this one. Okay, so it is mirror now already. So I'm gonna press done here. Then I'll try to mirror this one also on the other side. So mirroring that one, so I'm gonna select my line here, construction line, this one and this one, and I have my mirror line here. Then I'm gonna apply that one. So it's created now on the other side. So I'm gonna press done here. Then I'm gonna add my point, which is on the intersection of the construction line and intersection of the circumference of the circle. So clicking that one and this one and this one and then this one, just only to represent my reference for my working plane. So I'm going to finish my sketch here. Then let's go to our 3D model from my plane. So I'm going to use the normal to curve point. So selecting this arc or circumference of the circle, then we have the points. We have now created our plane. I will try to create my sketch here initially. So creating my sketch here, and I'll try to change my view, and I would like to project this center point. Then let's draw a circle here which shall be constrained on the center point. Then I'll try to give this one a diameter which is 10 mm initially. Okay, I'm gonna finish my sketch, and again I'll be drawing a plane which is normal to the curve point, and this one at that point. Then making my 2D sketch on this part file. I'm gonna change my view here and draw my circle on this point. So which is constraint and the center. Then giving this a diameter, no? So I'm gonna use the value of your 10 here. That will be D96. So that represents the represents the equation for this diameter. Then I'm gonna multiply this by 2 using the as the ratio represented one. So I'm gonna press enter. So okay, so that represents that one. So notice here, if I'm going to try to finish my sketch and I will try to change my diameter. So you notice here that it must be follow, no? So this one must also follow what is changes on this one, so dynamically, but you have to press this one in order this sketch will follow dynamically for this one. So I'm gonna press this lightning bolt symbol so to update the dimension for this one. So again, let's go back to the value of this one, which is 10 mm, okay, and try to update. So again, so it's so nice to see that you can do a parametric dimensioning on this one, so that is dependent on the other one. Okay, then let's try to make another plane. Making another plane which is normal to the curve point, so which is on this side at this point, no? Okay, so try to change that view, and let's try and make a sketch here. Then let's go to the 3D view and also try to change this one. Okay, I will draw again a circle here at the center point, and this one giving the dimensions. So again, I will use the diameter on this one. So you notice as I hover on my previous or initial diameter that I give into my initial profile. So as I hover my mouse, so just click the left mouse button. So you have D96. So previously that is 2 times the value is 2 multiplied by 2. Then this time I'm gonna give this one a 2.5 value to increase the value. So we have an increasing value. Okay. Then again, I will be making. So I'm gonna finish my sketch, then making my plane, which is normal to the curve point on this line and on this point. Then let's have a 2D sketch here. So go back to my views. Okay. Then this time I will try to draw again on the center. So forgot to project the center point. So let's try to do that one. Projecting that one, drawing my circle. Okay. Then providing this one a diameter. So previously we have there 10, no? So that is D96. Then I'm gonna multiply this one by 2.6. So let's try to make this one a 2.7 for the diameter. And let's try to finish my sketch now. So notice that is, so you can also continue this one, but for demonstration I will try to minimize my activity here, so just to show you the other features of using the Loft. Okay, I will be creating my Loft now. So launching my Loft features. So we have here this one for my sketch, and this one, and this one. So we have 1, 2, 3, 4 sketch. Then as I go to my top view, so you will notice here the projected features that is being created as we hover or select those sketch profile that we have made previously. If I'm going to change this one to rail, this one, this is a center line, then we need to represent what is the center line. Okay, so you'll see that it is follow along, so that one is being offset on the rails. Then if I will try to select my closed loop here, so we'll notice here also that there is an abrupt changes here. So because from the initial symbol here, so it tried to change its volume to be exact as the same as the previous one. So that's why if you're going to close that one, so you will notice that I'm going to break this one up. So you will notice that it is an abrupt changes of your surface volume here, or surface or your part features here. So that is the application of other applications of using the Loft. So that is the advantages also of using Loft. So it's a nice. Also here you can use this one for creating other part of your mechanical parts. So if it has a different size, especially especially making manifolds here in your designs. So that is the application. And let's try to remove this one. Okay, and going back to my view, and I will try to change the diameter of this one. So selecting my initial sketch. No, I already did my second sketch here. So let's try to do that one. So I'm trying to change this one as a 20 mm. So try to do that one. Let's finish my sketch and let's update our part file here. So it's being created. Okay. So that is the beautiful thing, application of using the Loft profile, Loft features.